talk about arc lengths now. So remember that when you see the word measure or the little M before the arc in these letters, this means degrees. Degrees. Measure equals degrees. Okay, now we're going to be talking about lengths, arc lengths. So when you see length, you're going to think distance, and that is not degrees. We're talking a measurement. And remember, the arc lengths are portions of our circumference. So we're going to find what that portion of the circumference is. Lucky us, we have a formula. Our lengths equal x times the circumference divided by 360. Now what is x in this? X is our degree measure of whatever arc we are talking about. And c is our circumference, so it is 2 pi r or pi times d. Okay, so again, length equals distance. We still are going to have to find the measure in degrees, but we are wanting to know the actual length, the actual distance here. Okay, so let's look at an example here. We're told in this circle G, FG is 27. So this is telling us our radius, and we want to find the length of FED. FED. So first step is to find the measure, so degrees. So we want to find the measure of FED. And we know that this portion is 90 degrees because it's noted by that little square that is 90. And if we take our total 360 and we know subtract 90 minus 47 minus 89, then we get that this portion, we get that this is 143 degrees. So now I'm going to add the 90 plus 143, and that is 233 degrees. Okay, so we're going to plug that into our length formula. So length equals the degree measure, 233 in this case, times our circumference, which is 2 pi r. So you can do this, 2 times pi, we know our radius is 27, and that all over 360. So if I multiply all that numbers at the top, I get 1258 times pi, which we're going to use 3.14 when doing our work. That way we're all rounding the same way. So if I finish off this math, I get roughly 109.8 yards. This does have measures. Well, I didn't include that in here. This is 47 yards. Because this is a length and it is a distance, it should have, depending on if I wrote it in the problem or not. But we need to make sure that we know that these are lengths and they're distances, not degrees. Do not mark this as 109.8 degrees. All right, this other example we've got here, we've got that VS is 12. So this is our diameter. And we want to find the length of arc UT. So we are looking for the measure, the arc length here. So we got to find the measure first. So this one we're going to have to do a little bit of work to get the measure. Okay, so we know that this one is 90, this one is 127. These right here are clearly vertical angles, so they are congruent. So if I can figure out this one, I can find this one, which will help us find this one. So this is our diameter, VS. So we know this is 180. If this is 127, I take 180 minus 127, and I get 53. Since these are vertical angles, this is also 53. This again is our semicircle. That's 180 degrees. This part is 90. This part is 53. So I take 180 minus 90 minus 53, and I get 37 degrees. So the measure of UT is 37 degrees. We're not done. We want to know the length. So length equals 37 times our circumference, which we're given the diameter, so we can do pi times 12 divided by 360. Okay, and whenever I do that math, then our distance is 3.87. All right, let me know if you have any questions. Again, make sure you are paying attention to measure versus length. Measure versus length.